Hello everyone and welcome back. In this video we're going to talk about Pascal's principle. Pascal's principle says that when a force is applied to a confined fluid, the change in pressure is transmitted throughout the fluid. So for example, if you squeeze a water bottle, that increased pressure is transmitted throughout the bottle and that pressure is the same everywhere in the bottle. In physics, machines help us do work by multiplying force. And a hydraulic lift is a machine that helps us do work by multiplying force that is based on Pascal's principle. Let's look at some of the key features and key points of a hydraulic lift. So the first thing is that a hydraulic lift consists of input and output pistons. So on the input piston you would push down and then the output piston would go up. And these two pistons are connected by a confined fluid. Secondly, the radius of the output piston is always going to be larger than the radius of the input piston. And when you push down on the input piston, you're going to increase the pressure in that system. And that increased pressure is going to be constant throughout the system. Next, the volume of water that you push down is going to equal the volume of water that is pushed up. And applying a force on the input piston creates a greater output force. And so we're multiplying force. That's why a hydraulic lift is an example of a machine. And lastly, the input distance will always be greater than the output distance. That's because machines trade force for distance. So that means I'm going to have to push down a farther distance than I'm going to get the output piston to raise up. So let's look at a few examples. In this example, it says that the input and output pistons of a hydraulic lift have diameters of 60 centimeters and 2.4 meters respectively. Let's add that to the picture. So if the diameter is 60 centimeters, that means that the radius is 30 centimeters or 0.3 meters. And if the other diameter is 2.4 meters, then this has a radius of 1.2 meters. What is the increased pressure in the compressed fluid if a downward force of 150 newtons is applied to the input piston? Let's add that to the picture. So when we push down on this input piston, we are going to create a pressure in the confined fluid. So let's calculate that pressure. Pressure is force over area. I'm pushing down with 150 newtons, and I'm pushing down on the area of this piston, which is circular shaped. So I used pi r squared, and I have increased the pressure in the fluid by 530.52 pascals. And that means the pressure in all of this fluid is going to be the same amount. All right, part B. It says when 150 newtons is applied to the input piston, what upward force is produced? So when I push down, I'm going to be moving fluid this way, and it's going to raise the output piston. So what is the force on the output piston? So this is where I can use Pascal's principle. Pascal's principle says that the increased pressure is constant in the fluid. So I know that the pressure over here at piston 1 has to be equal to the pressure over here at piston 2. So the pressure at piston 1 is force over area. The pressure at piston 2 is force over area. And I'm kind of just doing a ratio proportion for this. So if I push down with 150 newtons over this circular area of pi r squared, I am going to create an output force equal to, I called it F out, pi r squared. And the radius over here is 1.2. And I find out that the output force is 2,400 newtons. Part C says, what is the mechanical advantage of this system? So a hydraulic lift is a machine, and a machine multiplies force. and however many times the machine multiplies force, that is the mechanical advantage. So if I wrote that in terms of an equation, we could say that mechanical advantage would be the output force divided by the input force. So I'm putting in 150 newtons and I'm getting out 2,400 newtons. That means that this machine has multiplied my force 16 times. Part D says, if the input piston moves 2.5 meters, how high does the output piston rise? Assume the machine is 100% efficient. So there's really two ways that we can solve this problem, but I'm going to show you both because sometimes you don't have information for one and you are forced into the other and vice versa. So one of the ways is to look at it in terms of efficiency. So if this machine is 100% efficient, that means that the work input has to equal the work output. And the work input is going to be what's happening over here at the input piston. So work being force times distance. So the force input times the distance input has to equal the force output times the distance output. And you can see that I plugged in my numbers here and I solved for the distance output, and the output piston will raise 0.16 meters. So it's important to note that again, we're trading force for distance. We have a mechanical advantage of 16, so we're multiplying our force, but it's at the expense of distance. So I am pushing 2.5 meters, and it's only lifting 0.16 meters. The second way that you can solve the problem is to think about that the volume that you move at the first piston is going to be equal to the volume at the output piston. So when we look at the volumes, let's think about volume as length times width times height. So volume, length times width, could be considered area times height, meaning another way to write volume is area times height. But our area is not length times width. Our area is the area of a piston. So our area is going to be pi r squared times the height, and then pi r squared of the output piston times the height. And I plug in my values again, and you can see that I get the same answer. So again, it looks like the work part is easier, but sometimes if you don't have all the information, you might be forced into the volume method. Let's look at another example. In example 2, it says a hydraulic jack is used to lift a 1,200 kilogram car. The lift has a mechanical advantage of 12. The large piston has a radius of 4. Calculate the input force needed to lift the car. So we don't know anything about the size of the small piston. So that's going to force us to think about mechanical advantage. So mechanical advantage is the ratio of the output force divided by the input force. So mechanical advantage is 12, and the output force is going to be the weight of the car. So we're lifting a 1,200 kilogram car, so mg is the weight, and then I can calculate the input force. So in order to lift that car, it's going to take 980 newtons. All right, part B says, what is the radius of the small piston? So now we're going to calculate the size of that small piston. And there's actually two ways to do that. And again, I'm going to show you both because sometimes you won't have all the information and you may be forced into one way over the other. So the first thing that comes to mind is Pascal's principle. Pascal's principle says that since we have increased the pressure in the fluid, that the pressure at the input piston, it has to be equal to the pressure at the output piston. And pressure is force over area, and pressure at the output is force over area. So just plugging in my values, I have an input force of 980. I have a circular area, pi r squared, and I'm actually solving for this input radius. And I'm lifting the car. This is the weight of the car, the mg of the car. And the output is pi r squared. And we find out that the input piston must have a radius of 1.15 meters. So another way that you can calculate this is the concept of mechanical advantage. So mechanical advantage is defined as the ratio of the forces. But because Pascal's principle is really a ratio proportion, force out divided by force in, area out over area in, that also means that mechanical advantage is also equal to the ratio of the output area divided by the input area. So this is another way that I could have calculated the input radius. 12 is the mechanical advantage, pi r squared of the output, and pi r squared of the input, and got the same thing, that the input radius is 1.15 meters. So please file that someplace in your mind that mechanical advantage is the ratio of the output to input force or the output over input area, because that can be a helpful little trick sometimes. All right, the last question says, if the input piston is moved 5 meters, how high is the car lifted? So just like the previous example, we can actually answer this question two different ways. We could look at the concept of work, and we could look at the concept of volume. This time, let's look at the concept of work, and so we're making an assumption that this machine is 100% efficient. And if it's 100% efficient, that means the work input is going to equal the work output. So the force in is 980, the distance in 5 meters, and we are calculating the output distance, and that turns out to be 0.42 meters. One thing I always kind of do to check my answer is to make sure that the input distance, 5, turns out to be greater than the output distance. How about you try this one? Pause the video and then click play when you're ready to check your answer. Okay, let's check your answers. How much input force is needed to lift an 8,000 Newton pallet? I used Pascal's principle and I found an input force of 500 newtons. What is the mechanical advantage? I used the ratio of forces, and that is 16. If the pallet is lifted 25 centimeters, how far does the input piston move? Again, I can look at that in terms of work or volume, and I chose work, 4 meters. And how much work was done? How much work was done, I can look at how much input work was done or how much output work was done, because they're going to be equal. So I just chose the output work. What did I accomplish? I lifted the 8,000 Newton pallet a distance of 0.25 meters with 2,000 joules.